Okay, I'm going to go into some notes here on probability. This is from an Algebra 2 book. The first section is going to be getting totals. There's going to be two main ideas for the day. There's fundamental counting principle, which if you read this, it's a bit confusing, but essentially the key ingredient here is you're just going to be multiplying things. And the other main idea is about permutation and combinations, which is selecting from a group. With the fundamental counting principle, there's an example here. This is essentially not necessarily from one group, and we'll explain that when we get to permutation and combination. But here's number one. This is an example of fundamental counting principle. Jamie purchased 3 blouses, 2 jackets, 4 skirts. How many different outfits using a blouse, a jacket, and a skirt are possible? So she's maybe has a green blouse, a red blouse, a blue blouse, and 2 different types of jackets and 4 different skirts. How many different scenarios are possible? So I made a little T diagram here. So B1 for one of the blouses, B2, B3. You know, if she picks blouse 1, jacket 2, because there's 2 jackets. And then from there, you can go skirt 1, skirt 2, skirt 3. And this represents all of the different outcomes. Maybe blouse 2, but then with jacket 2, but then skirt with 1. And if you look at all the tree branches, the number of outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 different outcomes. Now you don't want to be making that tree branch every time. This is what the fundamental counting principle is. If you're just going to be selecting one item, then selecting another item, then selecting another item, all you need to do is multiply. 3 blouses, 3. That's your first pick. You got 2 jackets to choose from, times 2. Times that by 4 skirts, times 4. 3 times 2 times 4 is 24 different outcomes. So this is the fundamental counting principle, which essentially just takes, you got to pick an item from here, here, and here. They are not in the same group. All you got to do is multiply. Okay, and the next major idea in this first section is about permutation versus combination. What essentially you're going to have here is a group of people, a group of anything. And you are going to read the word problem, and first you're going to decide, is the order important when you're picking, the first person you pick, the second person you pick, is the third person you pick. Is that super important, or is it not important at all? Because if it's not important at all, it's combination. If it is important, it's permutation. So they give you an example here, 6 permutations for the letter A, B, and C. So what they're saying here is, let's say there was A for Albert, Brent, and Chris. There's 3 guys here. And for permutation, order is important. So maybe the first person you pick is going to be the president. The second person is going to be the vice president. And the third person is going to be the finance guy. So A, Albert is the president. B, Brent is the vice president. C, Chris is the finance guy, is totally different than Brent being president, Chris being the vice president, and A being the finance guy, which is different than Brent being the president, then Albert is the AP, and C is the finance guy. So this is permutation, where the exact order is important. And so they show all the different combinations that are going on here, permutations, excuse me, where president is the first person, second person is vice president, the third person is the finance guy. Combination is, you got 3 people, order doesn't matter. Just give me 3 guys. And so you see there's only one solution here, just ABC. ABC is the same as BAC, which is the same as CAB. It doesn't really matter. Just give me these 3 guys. Order does not matter with combination. They give a little formula here, and we'll get into this formula in a moment. This is about factorials. But you got to decide between permutation when you read a word problem where order is important, and combination, this is the backside here, where order is not important. So let's read the first problem here. And it is this here. Number 2. How many ways can a starting point guard and a shooting guard on a basketball team of 7 players, how many ways can you choose a starting point guard? So this is kind of like, you got to first decide, is this combination where order is not important, or permutation where order is important? And like the previous example here, when I said somebody's going to be the president, somebody's going to be the vice president, somebody's going to be the finance guy. Well, now in this one, it's going to be somebody's going to be the shooting guard. Whoops. The shooting guard and the point guard. And so order is important, because if I say AB is not going to be the same as BA, because somebody's playing the shooting guard, somebody's playing the point guard. And not only is there only 2 people in this example, there's actually 7 people to choose from. So first of all, is it combination order is not important, permutation is important? It's permutation. And then from there, they're going to ask, okay, well, how many different ways can I set this up with a group of 7? So there was a formula that was mentioned here on the front page. Here, I'll list it right here. It's going to be this. P for permutation. There's 7 people we get to choose from, and we're going to pick them in groups of 2. So based on this little formula here, and here's the formula for combination, but this is essentially, you go 7 factorial over parentheses 7 minus 2 factorial. You'll notice that 7 factorial, 7 minus 2 factorial for the combination, but they also include this. This would have been 2 factorial as well. You'll notice a little bit difference when we do a combination one. Okay, but this is, order is important, because we're going to pick 7 people on the basketball team. We're going to pick a starting guard, a shooting guard, and a point guard. So what this really means is simply this. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 minus 2 is 5 factorial, and that essentially means 5 times 4 times 3 times 2 times 1. Because with a fraction here, it's cancel, 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 cancel. This is really just 7 times 6, 42 different permutation ways that you can take 7 kids and mix them up. Johnny's the point guard, Joey's the shooting guard. Now Albert's the point guard, now Josh is the shooting guard. There's different ways to do it. There's 42 different ways. That's permutation. Okay, here comes number 3. Rosalie looks at one circular lock with 12 positions like this here. To open it, she turns the dial clockwise to the first position, so 1 through 12, then counterclockwise to the second position, then clockwise again. So there's 3 numbers. Write an expression for the number of 3 position codes that are possible. So how many possible combinations are there? No position is repeated. So you'll never get like a 5 clockwise, then 5 counterclockwise, then 5 clockwise again. So as soon as you use one number, you don't repeat it again. And this is order important. It's basically you're asking, is the combination 5 one way, 3 another way, and 7 one way, is that the same as 7, 5, 3? Would this open the lock? Well, no. So order is important, and that makes it permutation. And because it's permutation, P for permutation, how many different numbers were there on this combination lock? There were 12. So we're going to put 12 here. How many numbers do we pick to unlock the lock? Well, 3. Clockwise, counterclockwise, clockwise. So 3. So now, based on our new formula here, we're going to use this with this guy here. It will be 12 factorial, parentheses 12 minus 3 factorial. When you do this, 12 times 11 times 10 times 9 times 8 times 7, blah, 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 blah. 12 minus 3 is 9 factorial, so really it's just over 9 times 8 times 7 times blah, 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 blah. All of these guys would just cancel out. 6, 7, 5, 4, 3, 2, 1. And really, that's how many different ways you can solve this problem. It's 12, because there's 12 one way, minus one more number, 11 this way, and then minus another number, there's only 10 more options this way. So using this, there are 1,320 permutation, combination locks that can open this guy. Okay, number 4. Rosalie needs to buy 2 locks, but there are 13 types of locks to choose from. So maybe there's a green one, a red one, a big one, a small one, a key lock, a number lock, the ones where you just flick to a number. But there are 13 different types. How many ways can she just randomly choose 2 different locks? Now you gotta ask yourself, is order important? So that would be permutation, or is order not important, combination? For this one, all she needs is 2 locks. It doesn't matter if she picks the red one first and then the green one. That's basically coming out with the green one and the red one. It doesn't matter. So this is combination where the order does not matter. So we're going to put a big C here. There are 13 locks to choose from, and she's only choosing 2. Okay, well, this is the first time we're using combination here, and here's the formula for combination off to the side here. It's basically going to be factorial, 13 factorial. There's 2 locks involved that she's going to find over 2 factorial, and then you're also going to go 13 minus 2 factorial off of that. Okay, so again, this is the basic formula. On the top, this is 13 times 12 times 11 times 10 times 9 times 8. I'm going to stop there because it does go on forever. Over here, we have one extra little bonus compared to permutation and combination. This little extra, this is 2 factorial. So it's just 2 times 1. And then it's 13 minus 2 is 11 factorial. So it's going to be times 11 times 10 times 9 times 8, blah, 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 blah. 11, 10, 9, 8, 7, 6, 5. They all cancel out. Really, this is 13 times 12 divided by 2. And there's 78 different ways or combinations when you got 13 locks and you got to choose 2. But again, order is not important because a red and green lock is the same as a green and red lock. You're going to the cash register and you're buying the same scenario. So you don't want to count it twice. And that's why you divide by 2.